Greetings, Houdini Python students. This is Chris Rhoda, and in this lesson, we are going to be continuing our exploration of the all-powerful Who.Node superclass. Now, the first method we're going to work on is the parm method, and we're going to create a variable to represent our ball object. So I'm going to say ball equals the ball object that we saw here, and then what we want to do is start dealing with its parameters. So I'm going to create a new ball parameter variable. I'm going to call it ball tx, which is going to contain the tx parameter for the ball. So I'm going to say ball dot parm, and then given the path, I'm going to call it tx. It's going to return the parameter information for that particular parameter. However, we're going to talk more about what to do with this node during the next lesson in Who.Parm, so you have to wait to that. But what if you're excited and you want to say, okay, I want to know what its value is now? Well, you use the eval_parm method, and that evaluates a specific parameter and returns the result for that particular moment. So I'm going to say print ball.eval_parm, and the path for that is tx, and we see it gives us a value of 5, and the actual and actually, I don't know if you can see this, but the actual value of the Houdini param at tx now is 5. Now, if we wanted to get a whole list of all the parameters for that, we could use the parms command or the parms method, and that will return a list of all of the parameters for that object. So there's going to be a lot of them. So I'm going to return back to my for loop. So I say for parm in ball.parms. I'm going to print parm.name. And so this returned all of the available parameters for this node at this particular time. There certainly are a lot of them. Now, if we wanted to actually set the value of the parameters from the Houdini Python shell, we can do that as well. And we use the setParms command. And the setParms command sets the parameter values of a given node according to an input dictionary with parms as the keys and values as the new parm values. And this looks something like this. Ball.setParms, and I'm going to go and grab a dictionary here with new translational values. And so what I wanted to do is translate to a value of x in 6, y in 1, and z in -3. I'm going to hit enter, and we see that the ball shifted in place, and its new parameter values are 6, 1, and -3. Now, the next method that we're going to have to deal with is the actual inputs and outputs, and I want to go someplace where there's going to be a lot of inputs, and no place does that better than this blend node for the facial animation. And I'm going to create a new variable called blend equals, and I'm going to drag and drop this node, which has a million inputs into it. So if I wanted to find out all the inputs, then the inputs method will return a tuple of the nodes connected to this node's input. And this would look, we're going to have to go back to the for loop for this because it's going to be kind of a lot. So I say input in blend.inputs print input. And then we have a list of all the nodes that are flowing into that particular node. And the same works for the outputs as well. And I want to go into the output node, and this delete ISO head certainly has a lot of outputs. I'm going to create a new variable, ISO head equals this particular path. All right. And now I'm going to, outputs is the method used for that, and it's used the exact same way as the inputs. So I'm going to say for output in isohead.outputs, print out the value, print output. And then we're going to have the list of all the nodes that are outputted from that node. There are quite a few as well. Now we actually can use the Python Houdini to, whoops, I didn't want to move that. I'm going to go back up. Now we can actually use the Houdini Python to actually control the inputs and outputs of our nodes, and we use that using the set input method. Now the set input method, it says given an input index in a different node will connect the output from the different node to the input index of a current node. Now what does that mean? Now when we notice that this output node, or this node here, has two inputs, a 0th and a first one. It's got two of them. So we want to tell it to, all right, move the, instead of the sphere, put the new box object and send it to the 0th input of the red. So I'm going to create a new variable for red, say red equals this particular node, and I'm going to set the input. I'm going to say red dot set input, and I want the 0th input, and I'm actually going to drag and drop the whole new node box and drop it right in there because we need a node type in there. And we see that the connection changed from the sphere to the new box, and our display here moved from a nice little red sphere now to a nice little red cube. Now the next one we really can't see very well, and that's the cook. And the cook asks or forces a node to recook for either the current frame or a frame range, and the frame range is an inputted tuple. So this actually would look something like red.cook, and I'm going to put a frame range in here, 1 to 216 is 1, and we get an error. Oh, okay. So, oops, Coke. No, that's not right. All right, but it did get an error, and it said, okay, it wants some information. We need a bool type, and so that means that it needs to get permission to force recook everything, because that could actually change the way a lot of stuff actually looks. Okay, no error means that we're in a good state and it was cooked through the entire frame range that we gave it. Now the last method that we're going to discuss is the as code, and we've seen this before. And this as code method produces all of the Python code required to create the particular Houdini node, and we're going to go ahead and still use the default settings for as code. As we see, we still get a whole bunch of information. Now you can use as code to recursively descend down the entire node structure of this particular node, and I got to give you a warning, this command can be very slow with more complicated nodes, and as always, it's usually always more readable when outputted to an external file. Now, there are many more methods for the who.node class, and the ones discussed in this lesson should be sufficient enough to get you going. However, I highly encourage any Houdini Python user to look through the documentation on the who.node to get the full impact of what this class can provide. Now, during our next lesson, I will provide an introduction for the who.parm class. I'll see you on the next lesson.